Good morning, all of you. In today's lecture, we are going to study representation of cell. In the previous lecture, I was explaining the construction of Daniell cell. The diagrammatically representation of Daniell's cell is shown here. As I told you, for the construction of electrochemical cell, we require two single electrodes. One electrode is negative electrode, another electrode is copper electrode, another electrode is positive electrode. That is, there is a combination of negative electrode and positive electrode with the help of solderation. Okay. In Daniell cell, the negative electrode consists, the zinc rod is dipped in zinc sulfate solution. And immediately this reaction takes place. Zn get converted into Zn2 plus with loss of two electrons. Due to these two electrons, due to the evolution of this electron, this Zn acquires the negative charge. And this negative electrode in electrochemical cell is known to as the anode. The positive electrode in Daniell cell consists copper is dipped in copper sulfate. Immediately this reaction takes place. Copper to plus twice of Fe minus gives rise to copper. That is the reduction reaction. And because of this reduction reaction, this copper metal acquires the positive charge. And these two single electrodes are half cells connected with each other with the help of solderation. Externally with the help of metallic wire. And there is a complete construction of the electrochemical cell. And EMF of the complete cell EC is equal to ER minus EL. ER means reduction potential of right hand side electrode, reduction potential of this right hand side electrode, minus reduction potential of this left hand side electrode. The difference between these two reduction potential is known as EMF of the complete cell. Okay. Now we see here, for the construction of various types of an electrochemical cell, we require different type of single electrode or half cell. So to represent all the type of electrochemical cell by diagrammatically, it is impossible. So for every time, it is impossible to draw the sketch of the diagram of an electrochemical cell. And that's why electrochemical cell can be represented in a simple way. And today we are going to discuss the representation of a cell. So first, we are going to discuss representation of negative electrode. Representation of negative electrode. And negative electrode means the anode. So here, representation of negative electrode or representation of the anode. Okay. In Daniell cell, this is the negative electrode. That is, negative electrode consists zinc can be dipped in to the solution containing Zn2 plus. So Zn is the solid phase and zinc sulfate is the liquid phase. So whenever we can represent the negative electrode or the anode, at that time, first we can write the solid phase. Then we can write the liquid phase. So this is the negative electrode in Daniell cell. So for the representation of this negative electrode, we can write first the solid phase, that is Zn. And then we can write zinc sulfate. This is the liquid phase. So first we can write solid phase, then liquid phase. And these two phases are separated with a single vertical line. So this is the single vertical line which can be represented as separation. But for the representation of negative electrode, we have to remember that first we can write the solid phase, then the liquid phase. All of it. So this is about the negative electrode in Daniell cell. Another example. So this is the first example. Second example, hydrogen gas electrode. Hydrogen gas electrode. For the representation of hydrogen gas electrode, first we can write the solid phase. The solid phase is platinum is in contact with hydrogen gas. Pressure is P atmospheric pressure. So this is the solid phase. That is, platinum is the solid phase, and this solid phase is in contact with hydrogen gas and deep into the solution. Deep into the solution means then we can write the liquid phase. All of it. So solution which consists H plus ion. H plus ion. And here in bracket we can write activity of H plus ion. Activity means that is the concentration of the solution. Concentration of H plus ions into the solution. So whatever it may be, 1 molar, 2 molar, whatever it may be. So activity of H plus is equal to 1 molar, whatever it may be. So this is the representation. That is, first we can write the solid phase, then we can write the liquid phase. All of it. So for the representation of negative electrode or anode, we have to write the solid phase first. Solid. And then we can write the liquid phase. And these two phases are separated by single vertical line. Now we are going to discuss next representation of the positive electrode. Here, this is a positive electrode consists copper is dipped in to the solution containing copper 2 plus ion. This is the positive electrode. So we see here, next point is the representation of positive electrode. Representation of positive electrode. And we know that positive electrode is known as cathode. So representation of cathode. Representation of cathode. So in Daniel said, positive electrode is the copper rod deep into the solution containing copper 2 plus ions, the liquid phase. So whenever you can represent the positive electrode, at that time you have to write the first liquid phase. Here we have to write the first solid phase, but for the representation of positive electrode or cathode, we can write liquid phase. So here we can write copper sulfate. Then we can write the solid phase. Then we can write the solid phase. And this liquid phase and the solid phase separated by single vertical line. All of it. So this is the first example. And the example in Daniel said. All of it. Next, the representation of chlorine gas electrode. Chlorine gas electrode. So as I told you, for the representation of positive electrode, we can write first what? Electrolyte or the solution phase, liquid phase. That is the solution which consists Cl minus ion. And here we can write activity of Cl minus. And this line represent what? The separation of liquid phase and solid phase. So first we can write liquid phase and then we can write the solid phase. Means platinum is in contact with chlorine gas. Pressure is P atm. So this is the solid phase. What is solid phase? Platinum electrode is in contact with chlorine gas. G means chlorine gas and pressure is P atm. And here the liquid phase is, and this platinum can be platinum contact with chlorine gas deep into the solution containing Cl minus. So first we can write the solution phase, liquid phase or electrolyte phase. Then we can write solid phase. So this is the representation of positive electrode or the representation of cathode. So representation, that is the simple way of the representation of anode and cathode. For the representation of negative or anode, we can write first solid phase, then liquid phase. Solid phase and liquid phase. For the representation of positive, first we can write liquid phase and then solid phase. All of it. Last, representation of complete cell. Representation of complete cell. representation of complete cell. Complete cell. So we see here the combination of negative electrode and the combination of positive electrode with the help of salt bridge. Okay. Externally by metallic wire. Then how we can represent the complete cell? First we can write the negative electrode. Then we can write the positive electrodes. And they are combined with the help of salt bridge. And the salt bridge can be represented by two single vertical parallel lines. For example, in Daniel cell, the negative electrode is this Zn. In zinc sulfate, so this is the representation of negative electrode. So we can write here negative side. Salt bridge, they are combined with the salt bridge. So for the representation of complete cell, we can write two vertical single parallel lines. Two vertical single parallel lines. Two parallel. This is the representation of salt bridge. Now we can write the representation of positive electrode. So here first we can write, for the representation we can write copper sulfate, and then we can write copper. So this is the positive, so we can write positive here. All of it. So this is the representation of the Daniel cell. म्हणजे काय पहा, डॅनियल सेल मध्ये हा निगेटिव्ह इलेक्ट्रोड आहे आणि हा पॉझिटिव्ह इलेक्ट्रोड आहे. हा निगेटिव्ह आहे, हा पॉझिटिव्ह आहे. मग निगेटिव्ह इलेक्ट्रोड हा निगेटिव्ह इलेक्ट्रोड प्रथम तर सॉलिड फेज लिहायचं, नंतर लिक्विड फेज झिंक सल्फेट, आणि इथं निगेटिव्ह साईड आहे. ते दोन्ही कंबाईन कशाने केलेली? सॉल्ट ब्रिज. सॉल्ट ब्रिज कशाने? दोन व्हर्टिकल पॅरलल लाईन्स. दोन व्हर्टिकल पॅरलल लाईन्स. आणि राईट हँड साइड इलेक्ट्रोड कोणता आहे? कॉपर इन कॉपर सल्फेट. मग पॉझिटिव्ह इलेक्ट्रोड लिहिताना सुरुवातीला काय लिहितो आपण? लिक्विड फेज, म्हणून कॉपर सल्फेट लिहिलेलं आहे, आणि नंतर सॉलिड फेज आणि सिंगल व्हर्टिकल लाईन, आणि नंतर पॉझिटिव्ह. ऑल क्लियर? So for the representation of complete cell, first we can write negative electrode, then we can write positive electrode, and for the representation of salt bridge, we can draw the two vertical parallel lines. Two vertical parallel lines. All of clear? So this is the representation of complete cell. All of clear? Now we see here EMF of the complete cell. EMF of the complete. Next point is EMF of complete cell. EMF of complete cell. EMF of complete cell. EMF of complete cell is denoted by EC. EC. EC is EMF of the complete cell, and that is equal to ER minus ER. ER minus ER. So EMF of the complete cell is denoted by the letter EC. E is equal to ER. ER means EMF of right hand side electrode. That is the reduction potential of right hand side electrode. Reduction potential of right hand side electrode. ER, reduction potential of left hand side electrode. In this way, we can represent EMF of complete cell. And finally, reactions. Reactions. How we can write the reactions? We see here. Chemical reactions. We know that cell reaction. Cell reaction. So we know that on the left hand side, oxidation reaction takes place. So first we can write oxidation at left. Oxidation at left. What is the oxidation? In Daniel said Zn gives rise to Zn2 plus plus twice of E minus. This is the oxidation reaction. Zn gives rise to Zn2 plus plus 2E minus. Reduction reaction takes place on right hand side. So reduction at right. Reduction at right. So what is the Cu2 plus plus 2E minus Cu? Cu2 plus 2E minus gives rise to Cu. All of it. So the oxidation at left. So this is the half cell reaction of this single electrode or half cell. This is the half cell reaction of this half cell. So oxidation at left, reduction reaction takes place at right. And algebraic sum of this reaction is called as cell reaction. Cell reaction or overall reaction. So 2E minus get cancel out. So Zn plus Cu2 plus gives rise to Zn2 plus Cu. This is the cell reaction. This is the cell reaction. So we see here, in this way we can write the cell reaction. First we can write oxidation at left. On left hand side at anode. On right hand side reduction. And we have to take algebraic sum. This is the cell reaction. All of it. So in this way we can represent all these things. That is representation of negative electrode, representation of positive electrode, representation of complete cell. Then EMF of the complete cell. EC is equal to ER minus EL. And last, cell reaction. Oxidation at left, oxidation at right. All of it. तर काय पहा, रिप्रेझेंटेशन ऑफ कंप्लीट सेल म्हणजे काय? तर इलेक्ट्रोकेमिकल सेलमध्ये दोन सिंगल इलेक्ट्रोड लागतात. एक निगेटिव्ह इलेक्ट्रोड आणि दुसरा पॉझिटिव्ह इलेक्ट्रोड. आणि हे जे सिंगल इलेक्ट्रोड आहेत ना, याचे वेगवेगळे टाईप आहेत. मग आता कोणताही इलेक्ट्रोकेमिकल सेल घेतला, केमिकल सेल किंवा कॉन्सन्ट्रेशन सेल, मग प्रत्येक वेळेला तुम्हाला डायग्राम काढणे शक्य नसतं. त्यामुळं एक सिंपल वेनी सेल रिप्रेझेंट करायचं. मग त्यासाठी प्रथमतः रिप्रेझेंटेशन ऑफ निगेटिव्ह इलेक्ट्रोड, रिप्रेझेंटेशन ऑफ पॉझिटिव्ह इलेक्ट्रोड, रिप्रेझेंटेशन ऑफ. मग ज्यावेळेला तुम्ही निगेटिव्ह इलेक्ट्रोड रिप्रेझेंट करता त्यावेळेला सॉलिड फेज सुरुवातीला द्यायची, नंतर लिक्विड फेज. मग या ठिकाणी झिंक हा सॉलिड आहे आणि झिंक सल्फेट हा लिक्विड आहे, म्हणून या ठिकाणी Zn सॉलिड फेज दिल्यानंतर Zns होतो. आता हायड्रोजन गॅस इलेक्ट्रोडच्या बाबतीत प्लॅटिनम इज इन कॉन्ट्रॅक्ट विथ हायड्रोजन गॅस, म्हणजे हे सॉलिड फेज अगोदर दिलं सुरुवातीला, त्याच्यानंतर लिक्विड फेज. आणि या दोन फेज सेपरेट दर्शवण्यासाठी सिंगल व्हर्टिकल लाईन दर्शवायची, सिंगल व्हर्टिकल लाईन. पॉझिटिव्ह इलेक्ट्रोड ज्या वेळेला तुम्ही रिप्रेझेंट करता त्यावेळी सुरुवातीला लिक्विड फेज द्यायची आणि नंतर सॉलिड फेज, आणि त्या दोन फेज सेपरेट होण्यासाठी सिंगल व्हर्टिकल. येते लक्षात? मग अशा पद्धतीने निगेटिव्ह इलेक्ट्रोड रिप्रेझेंटेशन ऑफ पॉझिटिव्ह आणि रिप्रेझेंटेशन ऑफ कंप्लीट सेलला सुरुवातीला निगेटिव्ह इलेक्ट्रोड द्या, कारण इथं कोणतं आहे? निगेटिव्ह इलेक्ट्रोड आहे. कोणता इलेक्ट्रोड आहे? निगेटिव्ह इलेक्ट्रोड आहे, म्हणून Zn झिंक सल्फेट. हे कशाने कंबाईन केलेलं आहे? सॉल्ट ब्रिज. मग सॉल्ट ब्रिज कशाने दर्शवायचं? दोन व्हर्टिकल सिंगल लाईन. आणि त्याच्यानंतर हा पॉझिटिव्ह इलेक्ट्रोड आहे, मग कॉपर सल्फेट. सुरुवातीला लिक्विड फेज द्या. इथं पहा, सुरुवातीला आपण काय लिहिलेलं आहे? लिक्विड फेज, नंतर सॉलिड फेज, म्हणजे कॉपर सल्फेट Cu आणि सिंगल व्हर्टिकल अशा पद्धतीने. म्हणजे सुरुवातीला निगेटिव्ह इलेक्ट्रोड, नंतर पॉझिटिव्ह इलेक्ट्रोड. आणि दोन्ही सेल कंबाईन करण्यासाठी काय वापरले? सॉल्ट ब्रिज. त्यासाठी दोन सिंगल व्हर्टिकल लाईन्स, दोन सिंगल व्हर्टिकल, त्या दोन सिंगल व्हर्टिकल लाईन संपलं. अशा पद्धतीने रिप्रेझेंटेशन ऑफ कंप्लीट सेल. ओके. त्याच्यानंतर EMF ऑफ द कंप्लीट सेल, मग ते आपण पाठीमागच्या लेक्चरला पाहिलेलं आहे. EMF ऑफ द कंप्लीट सेल डिनोटेड बाय द लेटर EC. EC इज इक्वल टू ER मायनस EL. ER म्हणजे काय? रिडक्शन पोटेन्शियल ऑफ राईट हँड साइड इलेक्ट्रोड मायनस रिडक्शन पोटेन्शियल ऑफ लेफ्ट हँड साइड इलेक्ट्रोड. अशा पद्धतीने EMF ऑफ द कंप्लीट सेल डिटरमाइन करता येते, कॅल्क्युलेट करता येते. रिडक्शन पोटेन्शियल ऑफ राईट इलेक्ट्रोड, राईट हँड साइड इलेक्ट्रोड, रिडक्शन पोटेन्शियल ऑफ लेफ्ट हँड साइड, त्या दोघांचा डिफरन्स. आणि सेल रिएक्शन. आता सेल रिएक्शन म्हणजे काय? तर या ठिकाणी लेफ्ट हँड साइडला ऑक्सिडेशन होतं, राईट हँड साइडला रिडक्शन होतं. ऑक्सिडेशन ऍट लेफ्ट इथे लिहिलेलीच आहे, ऑक्सिडेशन रिएक्शन, रिडक्शन रिएक्शन, त्यांचा अल्जेब्रिक सम घ्यायचा. मग दोन इलेक्ट्रॉन कॅन्सल होणार. मग Zn प्लस Cu2 प्लस Zn प्लस Cu2 प्लस, त्याच्यानंतर Zn2 प्लस Cu, याला म्हणतात सेल रिएक्शन. येते लक्षात? अशा पद्धतीनं रिप्रेझेंटेशन ऑफ कंप्लेक्स. ओके, I will continue in next lecture.